first we will go through the problem statement. Here it says you are given the head of a linked list. You have to replace all the values of the nodes with the nearest prime number. Okay, if more than one prime number exists at equal distance, then choose the smallest one. Okay, so here in problem it's simply saying that whatever the nodes we are given in the linked list, we have to replace each value of the node with the nearest prime number. If the particular node value itself is a prime number, then we do not have to do anything else. We have to replace it with the nearest prime number. And if in any case we have the number smaller than the particular node value and the number higher than the particular node value, if both are at equal distance, then we have to choose the smaller one. So here they have given two examples. Let's first go through them. So in first example they have given 2, 6 and 10. So the nearest prime of 2 is 2 itself. The nearest prime of 6 are 5 and 7. Since 5 is smaller, so 5 is chosen. 5 will be chosen. The nearest prime of 10 is 11. So this is one example. So the nearest prime number to 6, it is both 5 and 7, but we have to choose the smaller one because in question it has been asked to do so. Let's go through the second example. Here it is said 1, 15, 20, and it is said that nearest prime number of 1 is 2, 15 is 13, and for 20 it is 19. The nearest prime number of 1 is 2, 15 is 13 and 17, but since we have to choose the smaller one, so 13 is chosen, and the nearest prime number of 20 is 19. So what we will do, we will iterate through each node of the linked list, and we will just try to find the prime number which is nearer to that particular given value. We have to take care that we need to take the smaller value. So with keeping this in mind only, let's start solving this problem. So first what we will do, we'll just store this node this value of head in some different variable, calling it as current is equal to head. This is needed in case of linked list because we need to preserve the head of the node each time, because whenever we return or we iterate, we have to iterate through the head. So that's why I am just assigning it to current, and I'll be performing some operations while changing the value of current. So the next thing is just run a loop saying that do the following operation till the current value becomes null. So current is not equal to null. Then perform the below operation. Here what we need to do, we need to replace the value of the current node value with the one with the prime number 1. So we will simply call a method called get prime, and we will pass the current value. So based on the value which is being passed from this one, it will try to calculate whether this value itself is a prime, or a value smaller than this is the prime, or the value which is greater than that, this number is a prime. But in that case also, if something is nearer, then we have to if both are at equal distance, then we will choose the smaller one. So this method will give you the desired value. So we will pass the value. So this is done. Now after that, we will just once this node is done, then we will just assign current to current next. We will be performing the same operation for each node. So now this is done. So this is the value enter here. So now we will create that method whatever we have written here, get prime. So here it will return the integer value that which we are assigning to this current value. So simply I'll just give the return type as int and call this method get prime, and we will again accept the value whatever we are getting from there. Just give its name data, some data we are returning and getting in this one. So first we will check if the number whatever we have got, if this is the prime or not. So what we can do, we can call is prime method again, and we will simply pass the data. So is prime is the method which will check whether this particular number is a prime or not. Once this is done, if it is prime, then it will simply return that particular data only. But if this is not the case, that means that particular number which we have passed in this get prime method, if that is not a prime number, then we need to find the next prime number. That means the nearest prime number to that value. So for that, I'll initialize a variable saying int I is equal to 0, and I'll run a loop there saying while it is true, then we need to again check if is prime of data minus I. If this is correct, then from here we can return data minus I. So what we are doing here, if the number which we have got in this get prime method, if that is not a prime number, then we are checking if whether a number that is before that, so instead of using with 0, we have to initialize it with 1. So data minus 1, so that will be one number previous to that number which we have passed through this method. So we will check if that number is a prime or not. If that is that prime number, then we will return that simply that value. If this is also not the case, then we will check if data plus I is the prime number or not. Sorry for the background noise, guys. Some construction work is going on. Once this is done, then we need to simply increment the value of I. So here what we can see, the reason of doing that data minus I is the first one, because in the question it is said that if two values are at equal distance, then we have to take the smaller one. So if two values are coming at equal distance, then we will be taking the value with the value data minus I. So once this is also done, then we'll simply increment I plus plus, so that for the next iteration I will become 2 and it will check for data minus 2 and data plus 2. Even when this is done, now we have to simply create one method which will check whether a number is prime or not. So for that we have some standard code to write, and just to save some time, I've just copied this one. Well, this is the standard code of checking any prime number. So now we are just checking whether this given numbers are prime or not. We are passing this one. If it is 0 and 1, then we are returning it as false. Else we will check whether for other scenarios if it is having some other divisor or not. So I think I'm pretty well done with my coding. So let's try running this code. Okay, sorry, we need to return here the head so that it can iterate over the complete linked list. Okay, so here we can see we have got our desired output. So let's try submitting the solution now. So here we can see we have got all the test cases covered. So we have solved this problem successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel. Thank you for watching.